In this video, we will solve problems using Rolle's theorem or the mean value theorem. Here from exercise 1 to 6, we need to see whether these problems can be solved by Rolle's or the mean value theorem. But before that, you need to understand two important rules. For both Rolle's and mean theorem, first thing is the given function must be continuous at the given interval, continuous. And second one is differentiable. It must be differentiable. Okay. So these two are very important conditions. And then there is another condition for Rolle's theorem. For mean value theorem, if this condition is not met, then we do mean value theorem. But since this is in writing exam, let me write in detail. Now, if this is the given question, what do you do? Now, before we start the question, I just want to note, see, all your exercise problems are polynomials. So you are very lucky. You don't have to worry about it. All the problems given to you will meet the condition 1 and 2 because polynomials are continuous everywhere and differentiable everywhere. So let me write it out. Here, first thing, f of x is continuous at the interval. You should write it as closed interval -2, 2. This is very important. Now, continuity means there is no breaks. It's continuous function. There is no asymptotes or no holes or no jump discontinuity, nothing like that. So that is important. Now, what about the next statement? After this line, write again, f of x is differentiable at, now always remember differentiability will be at open brackets -2, 2. So this is the thing. These two statements are very important, and when it's polynomial, always these hold good. Over here, if there are different limits, intervals, change these accordingly. These two will carry, these are like, important hypothesis, and then only you can go ahead with these two theorems. Now, next, what do you do? We need to know whether we use Rolle's theorem or mean value theorem. For Rolle's theorem, there's a condition. Now, these limits, right, these intervals, we consider them to be a and b, okay? Over here, f of a must be equal to f of b. If this condition is met, we use, if this is met or this holds good, then only we use Rolle's theorem. Otherwise, we go to mean value theorem. Let's see how does it work over here. Now, we have the given function f of x. If you want to solve for f of a, what do we do? Instead of x, we put a squared plus 1. That's it, right? But now, what is the a value? It is -2. So what happens here? Instead of a, I'll put -2, and the entire thing is squared plus 1. What is the answer? It is -2 the whole square is +4 because minus becomes plus. When you square it up, +1 will be 5. What about the next one? F of 2 only. So it'll be just 2 squared plus 1, right? Instead of x, I put 2. Over here, instead of x, it was -2. Again, it's the same thing. 4 plus 1 is 5. Now, here you can say f of a equals f of b. Or you can use these terms itself. Now, instead of a and b, I feel that it's better you write the interval itself. I'll write over here f of -2 is equal to f of +2. Hence, or therefore, or hence, we can use Rolle's theorem. Rolle's theorem. So this is the thing. Now, these three statements are very crucial. Now, after this, we can easily start solving everything. I mean, solving the Rolle's theorem. We can apply it. Now, what Rolle's theorem says is, if these three conditions are met, the first, second, and third, you can write in 3 lines, then the derivative of this particular function at a point C will always be 0. So if these both are equal, the function will be something like this or like this, because they always come back, right? So even if it decreases, it'll come back to the original point. So you will have a slope of this given function. The tangent the tangent is 0, like the slope is 0 over here, slope of the tangent line. Even over here, you will find that because it will come back to its original position. So that's it. Now let me just remove that and let me start solving the problem over here. So what do we do? Instead of writing x, we are writing it for a value c. So what is f of c here? That would be just instead of x, I put c to the power 2 plus 1. Now consider this as a variable and let's derive it. F dash of c would be, just imagine this was x, it would be 2x, right? But instead of x, we have c. 2c plus 1 will be 0, so I'm going to ignore that. So now what is the derivative of f dash of c? It is 2c, that is equal to 0. So what is the c value? It is 0. So this is important. So now we got the c value is 0. Whether it's within the range? Yes, it's within the range. And now they're also asked you to graph it. After this much, after these three important lines, even this must be written. You need to graph. You can directly get the graph points from the table option in your calculator. Let's go over there now. To graph any function in calculator, you just have to press mode and then 7 for the table option to get the points. Now type the given function. It is alpha x squared plus 1. That's it. Now, most of your calculators, if you have a similar calculator like this, you won't get this option. But if you have the latest model, then you will get this option. Ignore it. We have just one function to graph. I just press equal to. Where do you want to start? Now, these given values are there, right? These intervals, we have to start at the lowest point, that is lowest number is -2. That's a value. And end it at 2. Now, if you put a step of 1, what happens is you will get the points -2, -1, 0, 1, 2. That is okay, but even if you want better understanding, you can give a step of 0.5. But now I'll leave it as 1 only and I'll show you what it means. Now here, I hope you will get a graphing, coordinate plane like this, with x and y axis. So here, where is x -2? Somewhere over here, right? So the y value is 5. So at x -2, imagine this is 5, you will have 1 point here. What about this? At -1, you have 2. Imagine this is 2. At -1, this is the point, second point. At 0, it's 1. This is another point. And let's just go down here. And since it's a parabola, it's a parabolic graph, it will repeat itself over here. At 1, we will be having 2. And lastly, at 2, we will have at 5. And then you just join these points. Just join them carefully. That's it. That will be the answer. Now, if you look carefully at c value of 0, that is x value over here 0, you can see it turns, right? There, it's a flat line. The slope is 0. Slope of the tangent line will be 0. So this is how we graph it roughly. You don't need to accurately graph this. This is more than enough. If you have a coordinate plane, it will be more accurate. Mine is just approximations. So you can see this is more accurate. And that's it. That's the answer. C value is 0. But see, over here they have written it in a paragraph. But I would highly recommend you to write it like this. On the left side, you can write below this and write the statement f of x is continuous at -2, 2. F of x is differentiable at this particular limit. But here it's open bracket, here it's close bracket. Differentiable always will be in open bracket. Now, similarly, we can solve the other problems. The same concept, but I think so. This is a mean value theorem problem. Let's look into it. Yeah, it'll be 0 and 2, right? It'll change. So first thing is the function f of x is continuous, okay? Continuous at 0, 2. The same statement what I've written previously, you must write it. Second, the given function is differentiable at 0, 2. This is open bracket, open brackets, small brackets, you can say. And then now we will solve for f of, this is a and b. F of a, that is 0, would be 0 squared plus 1, that is 1 only. F of 2 would be, here whatever x is there, you put 2. 2 squared is 4. Let me write it, 2 squared plus 1. 4 plus 1 is 5. Do these match? They don't. So you can write over here the third statement, f of 0 is equal to 1, f of 2 is equal to 5. Therefore, or hence, we use mean value theorem. So just copy the statement over here from the question. And now what do you do? For the mean value theorem, The derivative of the c function, the c value, will be given by a formula. It is like a slope formula, y2 minus y1 by x2 minus x1. Now instead of y2 we have f of b. The second point, I'll just change this over here. The same thing, the slope formula, y2 minus y1, right? F of b minus f of a divided by b minus a. This is it. Now what do you substitute? You have f of b, f of b is over here. Let's substitute directly. F dash of c would be, no, before that, I need to find f dash of c. See, now f of c is c squared plus 1. Let me differentiate this. F dash of c would be 2c plus 0. Same like the last problem, just the limits are changed. Now here what we do is, this particular 2c value is over here under f dash of c. Okay, so it's just that we will put 2c, and over here f of b would be, b is how much? 2, so that is 5 minus f of a is 0, and this is the value, 5 minus 1 divided by, what is b value? It's 2 minus 0. Let's solve it up. It's 2c is equal to 4 by 2. 2c is equal to 4 by 2 is 2. C is equal to, divide both the sides by 2 over here, and here it will get 1. So c value is 1. That is the answer. Now these two statements are very important, and the third statement determines which theorem to use, whether it's Rolle's theorem or mean value theorem. And now what we do is we just graph. Now how do we graph? Using the calculator. We had just now graphed this, but only there is a difference in the start and end point. Now what you need to first do is go to mode 7 for table method to graph to get the table of values. Alpha x squared plus 1, and now when you press next, ignore this if you're getting this. If you're not getting, well and good, you will get the start option. Start is always at the a value. Let me take 0. Now I won't end at 2 because if sorry, I have to end at 2. Sorry, this is correct. Now I won't give a step of 1 because if I give a step of 1, look over here, I just get 3 values. This is fine, but still it's not so accurate. You can graph with 3 points, it's fine, you can go ahead. But what I would suggest is, for a better graph, this is the given equation. Starting is at 0, ending is at 2, and just give the step of 0.5. Now what it makes is, you will get values of 0, 0.5, 1, 1.5, 2. You will get a more depth in the graph. There will be more points to plot. So then we will plot, and over here now, since we are starting at 0, it's over here and it goes up and up. That's it. That will be the graph. Okay, you need to plot it accordingly. If your coordinate plane, it will be much easier. Now you must only focus on the region 0 to 2. This is it, 0 to 2. And you can see in your calculators, you got these points. Now at 1, where is at 1? At 1 over here, you can see there will be a tangent line. The slope of the tangent line is 0. That's the tangent line drawn to this particular graph. So that's it. The answer of C is 1. Now one more thing. What is this line specifying? When this line is drawn, it touches only one point of this graph. At 1, there will be only one point, and everything will will not touch the graph. Now if you draw a line like this, what does this mean? This is a secant line which touches more than one point. When it touches only one point, it's a tangent line. The same concept is going to be continued anymore. Now first thing, continuity at 0, 1, close brackets, 2. Now this is also polynomial, so differentiable at small bracket 0, 1. Now next, what do? Is we see whether a and b are equal. F of a is directly, I'll write 0. It will be 0 plus 0, that is 0. F of 1 will be 1 cubed plus 1 squared. That will be 1 plus 1, it's 2, because 1 to the power anything is 1 itself. Now these both are not equal, so f of a is equal to 0. You can write over here directly the value is 0, f of 0, and f of 1 is equal to 2. Therefore we use these 3 dots, means it's therefore, okay? Or you can write hence. We use mean value theorem. And then what we do is we use the formula of mean value theorem. F dash of C is equal to, you should write the formula f of b minus f of a divided by b minus a. Now here let's find f of c, that is equal to c to the power 3 plus c squared. And over here we will have 3c squared plus, now over here it will be 2c. Now this is derivative of c. Now substitute this under f derivative c, 3c power 2 plus 2c, that is equal to, what is f of b? That is f of 1 is 2 minus 0 divided by 1 minus 0. It's basically 2 divided by 1. It's 2 itself. This entire thing is 2. Now let's take this 2 to the other side. It'll be 3c squared plus 2c minus 2, that is equal to 0. Now this is a quadratic term. How do we solve it? Is in the calculator using mode 5.3. If you have your default mode in the calculator, then just go to mode, equations. This is the equation. It's a quadratic equation, power 2, that is mode 5 and then 3. And now type in the coefficient 3, 2, minus 2. What's the answer? Now don't write this in fraction form, just press SD. Let's write in decimal forms. It'll be x is equal to 0. I'll write 2 decimal only, 55. And what about the next answer? It is negative 1.21. X is equal to negative 1.21. Now, which is the correct answer? Which is within this limit? 0 and 1. It's only this is the correct answer. This should be ignored. You can, oh, it's C value, okay? So therefore, C is equal to 0.55 because that is the only area of consideration for us. This is the intervals, right? So we should graph now mode 7 and write this equation, x to the power 3 plus x to the power 2. And over here starting is, this is not there, starting is at 0, ending it at 1. Now please, here you have to use the step of 0.5 and you get these values. And now you can see the graph over here and you can even compare these values. At 0.0, the y value is also 0. See, 0, 0. Now at 0.5, somewhere over here, what is the y value? It's 0.375. Yeah, that's accurate. It's somewhere over here. At 1, it's 2. Let's check. At 1, it is 2. Yes. At least 3 points are enough because you will have points. Let me just draw it over here. From this, and this one. Okay, you get these 3 points. So you understand it's going up. So just draw a smooth curve. I mean, it's okay if it's not very accurate. You have to just try how much you can. Okay, for this case. And then at which point over here, where is the C value? It's 0.55. Somewhere over here will be the 0.55 would be the tangent line. Just draw a straight line at 0.55. Graphing is important. See, after this graph, you have to draw the straight line at which point? 0.55. Don't consider negative 1.22. You should not consider this. It's only this. So this is the correct answer. Just remember what I wrote. If you just write this, it's more than enough. Everything is in detail in this. Just make sure you complete the sentence. I written properly in the first question, right? Just follow the same thing for writing. Now this is again the same function, so I won't do it. Only the interval values are changed. So you need to do the same 3 steps. You need to do continuous, differentiability, and then check whether f of a and b are equal. You might think, oh, it's 1 and 1, negative, will it be gone? No. F of b is, let me do b first, will be 1 cubed plus 1 squared, that is 2. But what about f of minus 1? Here will be minus 1 the whole power 3 plus minus 1 the whole squared. So what happens when you have odd power and there is negative number? It'll be negative itself. Negative sign remains. When it's even number, the negative sign will be multiplied itself and be positive. So in this, it'll be minus 1 plus 1. This is 0. So here, f of a would be 0. So you can see this is not equal. So we have to use mean value theorem. 2 minus 0 by 1 minus of minus 1. Why? Because this is minus and minus 1. So it's 2 divided by minus and minus becomes plus. 1 plus 1 is 2. The answer is 1. Here this is 1, but what is the derivative of this? We have done that before, right? Just make sure you make it equal to 0 and bring it inside and solve it up. You'll get the answer. See, now here the c value is 1 by third, and when you graph it up, you get this over here. We had got only so much in the last problem, but now you have other points as well. So in the graph, you will get, see, this point, you'll get this point, you'll get this point, some points, and then just join them. And look over here, 1/3 is what? 0.33. So somewhere over there, you have to draw a straight tangent line. You need to use a scale to draw the tangent line here to be accurate. Now in the last two problems, we have trigonometric functions. So here there are a few things you must remember. Whenever you have trigonometric function, please use radian mode. R is for radians. I'll show you how to use it in the calculator. And make sure you use calculator if you're getting confused. Directly pi by 2, everything is available in calculator. Okay. If you memorize the values, it's well and good, but double check using calculator for everything. Now it's the same thing. It's just that this is a little bit different. First step is what? Continuity at, here open bracket 0 comma pi by 2. What is pi by 2? How much degrees is this? Pi is 180 degrees. Pi by 2 is 90 degrees. Second is differentiable. When it's differentiable, this will be open small brackets 0 comma pi by 2. That's it. And what about this over here? Third one, we need to find f of a and f of b. Let us solve whether they both are equal or no. So f of a is 0, sine 0 is always 0, sine 0 is 0. What about sine pi by 2? Sine pi by 2 is, sine 90 is 1, so sine pi by 2 is 1. But I'll just use the calculator to show you how exactly you get these values. Let's take our calculators now. Here first, few things. Let's just clear our calculator. Shift 9, 3 equal and AC. That's cleared. Now, always a default mode of a calculator will be in degrees. How to make it in radian? Whenever you see trigonometric functions, use radian. That is by pressing Shift and mode. And then the option number 4, rad, is radians. Now you can see R is over here. So now it's in radian. Now sine. If you have anything in pi, you have to make it in radian. If it is in degrees, you just keep in degree, shift mode and 3, you know. But now we have in pi, so it's shift and pi here. Don't write 3.1 for shift and pi is very important, right? Divided by 2, and then just close the bracket. What is this? It's 1. So this is how we do it. If it was cos, it'll be 0. Cos pi by 2, 0. So that's how we get it. Okay. Now, this is how we check both the values. And now we know f of 0 is 0 and f of pi by 2 is basically 1. Therefore, we use mean value theorem. Now then, let's write the formula. F dash of c will be equal to f of b minus f of a divided by b minus a. What is f of c here? F of c is sine c. Let's derive it. F dash of c or f prime of c will be cosine c. Now don't put a negative sign because sine derivative is just cosine. That's it. And this is the answer. Now let's write over here f derivative is cosine c, that is equal to, what is f of b? F of b found, it's 1 minus f of a was 0 divided by b is pi by 2 minus, so 0. Let's rearrange. Cos c is 1 divided by pi by 2. So now what does this become? Yeah, 1, this again pi divided by 2. So when we rearrange this, this goes up, isn't it? Now here, look, this is 1 divided by, there's a fraction. It's like this pi by 2 is a fraction here. So this goes up over here in the numerator. So it'll be 2 by pi, basically. So when you simplify this, it's going to be 2 by pi. Or you can leave it like this because you're going to use calculator. So anyways, the answer will be same. C will be cos inverse of any of this. It'll be 2 by pi. So let us use a calculator and check the answer. In order to get the inverse function, you need to press shift and cosine. It'll be cos inverse. So first I'll use this 1 divided by pi by 2. That is shift pi divided by 2. You can write everything as it is, and the answer will be 0.88. Now I'll just change this over here, and I will write its pi, and over here what do we have? About 2. It should be 0.88. That's the same answer. So anyhow you do, you will get the answer. Now this is the solution. You can see the final answer C will be 0.88. Now how do you graph? Graphing is simple. Just use the calculator again, mode 7. We press mode 7 and then type the function sine alpha x, close the bracket. Remember, it must be in radian mode, and it is in radian mode. Let's start at 0. Let's end at pi by 2. Okay, it's pi, shift and pi. Now the fraction symbol will be like this, or you can write divided by, it's the same thing, divided by 2. And what is the step you want? Now don't take step of 1, 2, 3. You should take in terms of pi. So 0 to pi by 2, it's 90 degree. I would take like something 30 degrees, 0, 30, 60, pi, 90. So 30 is basically pi by 6. I'll just divide this by 3. There is a way to easily solve this. Whenever you have 0 and then you have pi by something, pi by 2, right? If you want, say, 3 points over here, just divide both by 3. It'll be 0 to pi by 6. I mean, just this value you should just divide by 3. So you put the step pi by 6, you'll get 3 points in between 0 and pi by 6. So let me put shift pi divided by 6, and now you will get 3 points, that is over here. These. Now remember, 3 points in between. See, after 0, 1, 2, 3, and this is the ending point. Okay. Now remember one important thing. You will not have in terms of pi, you will have the value. Now what does this 1.5707 mean? This means it's pi by 2, the ending value. Pi by 2 is pi 3.14 divided by 2. This is the value. Now what this means, it's all pi divided by certain values. Now here if you analyze carefully, this is 0, pi by 3, pi by 4, pi by 6, pi by 2, and so on. Pi by 6, pi by 4, and pi by 2. So you need to analyze this thoroughly, and then even if you don't understand them, it's fine. Just put this x value and y value. Let's look over here in the graph. You can see this. Where is the 0? At 0, it's 0. So this is the graph. And then at 0.52, where is 0? Somewhere over here. What is the value? 0.5. So at 0, so can you see it corresponds? You need to plot the point. That's it. At 1.04, where is over here somewhere? You need to have 0.866. Yes, that is approximately correct. Yeah, obviously it's accurate only. And 1.57 would be the last point at 1. So then you just draw. And what is the value you will have? The C value, the tangent line at 0.88, right? Where is 0. Somewhere over here? There'll be a tangent line for the graph. So this is how you solve it up. Now again over here it's the same graph, but it's negative pi and 0. I guess it's Rolle's theorem over here, because pi is again 0, sine 0, 0. Yeah. So here you have negative pi and 0. Only thing is, this is going to be Rolle's theorem. See, the f of pi minus pi and f of 0 will match. Let me show you how this is exactly done. See, step 1 is continuous. You should write this is continuous. Step 2 is differentiable. These are very important statements. Next one, we will do f of minus pi equals sine negative pi. Sine pi or negative pi will be 0. What about f of 0? Sine 0 is 0. Since third statement, f of minus pi is equal to f of 0 is equal to 0, we use Rolle's theorem. So this is important. And then now Rolle's theorem is the most simplest one. F prime of C is equal to 0. That's it. Derive this function. F of C first. Write this. It's important because it's writing exam. You need to write everything in detail. Sine C. Then what is f prime of C? Just derive the above function. It will be cosine C. So now cosine C would be equal to 0. Now take cosine to the other side. C would be cosine inverse of 0. And just put in the calculator. Cosine inverse of when is, see now this, the way to understand is, when will cos function be equal to 0? Cos function is always equal to 0 when it's at 90 degrees, right? So Yeah, at 90 degrees it's 0. So the answer over here would be C is equal to cos inverse would be pi by 2 or 90 degrees. And if you can do it in the calculator, you will get that answer, okay? It's pi by 2. Now here, I forgot one important thing, guys. Now this can be easily obtained in calculator, but if you're thinking how exactly, now if you know the, cosine function, what happens? It starts from up, right? It goes over here, it comes down, it goes up like this, right? So this is the function. And now at the left side also it happens the same thing, okay? When does it touch 0? When is it 0 over here? At cosine 0, it's 1. When the y value is 0 is at pi by 2. Here pi by 2 and here it's minus pi by 2. Since we are dealing with the limit of minus pi from here to here only, which value does it touch 0? It will be at minus pi. So we have to take negative here. Now if you put it in the calculator, cosine inverse 0 is pi by 2. But look, just add the negative sign because we are going towards the left axis. Is that clear? From 0, negative pi by 2, minus pi. That's why this is the interval given to us. Therefore, we take pi by 2. Okay. Right side will be pi by 2. Yes, it will touch 0 over here. But we are taking the left side value. That will be negative pi by 2. That's the only difference. So that's an important, crucial thing. And then you know how to graph from mode 7 in the table. You get the points and graph it up. And here you can see it minus pi by 2 is about negative 1.57. There's a tangent line. So this is how we solve the question number 19, which is about Rolle's and mean value theorem. That's the end of this question. See you soon in the last writing question.